can begin. We've got a decent crowd here already, so take it away from us, Michel, please.
All right, so good morning, good afternoon, everyone. Thanks for being there, and get ready because we're about to challenge the status quo of AI solution. So I am Michel, the CTO of Mimik, and today we're not just talking about AI, we're talking about liberating AI, unleashing its full potential by operationalizing agentic solution that breaks free from rigid and costly and centralized cloud model. So at Mimik, we believe that intelligence should not be trapped in far-off data center. The future of AI is decentralized, dynamic, and right at the edge, where data is generated and decisions need to happen instantly. So the problem is traditional AI are obsessed with cloud. The centralized server process everything, creating latency, privacy risk, and scalability nightmare. So why AI models should wait for cloud instruction when they could act autonomously right where they are? And the solution is operationalizing agentic AI at the edge. This is where we flip the model on its head. And instead of making device passive data collector, we turn them into autonomous and intelligent agents. And these agents sync, collaborate, and act locally, reducing dependency on the cloud while enhancing speed, security, and cost efficiently. So at Mimik, we've built the infrastructure to operationalize agentic solution at scale, allowing AI model to run independently yet cooperatively across diverse devices, from smartphone to industrial system. This is not just edge computing, this is AI with agency, AI that can self-organize, self-optimize, and operate seamlessly across distributed environments. So that's the next frontier of AI, and today I'm going to show you exactly how can we make it happen. So let's dive in. First, let's talk about agentic solution because we're hearing this term a lot. They're thrown around a lot, but what do they actually mean? Where do they even begin? Like from execution to deployment, from a single agent to an entire ecosystem of agents working in sync, from one vendor to a sprawling web of providers. The challenge is not just about making AI work, it's about making it work together. So if it sounds familiar, it is, because it is. Like back in the Web 2.0 era, people tried to solve fragmentation by hacking together mashups, stitching services together to create something greater than the sum of their parts. It was creative, it was chaotic, and it was a mess. And now we're seeing the same history repeating itself with agentic AI. Everyone is racing to bring disparate AI together and the model together, and something crucial is missing. Something that will separate game-changing innovation from a disconnecting tangle of half-baked experiment. And what is this missing piece? The ability to operationalize agentic AI, to turn fragmented intelligence into seamless, scalable, and truly autonomous system. It's about making simplicity emerge from complexity, and not by brute force, but through intentional, intelligent choreography. And that's exactly what we're solving, and today I'm going to show it to you. So hybrid edge AI, it's not just a buzzword, it's an evolution. It's about shifting AI from passive cloud-reliant model to autonomous, self-improving, and choreographed intelligence at the edge. So let's breaking it down. First, you have local. Stage one is local execution. So AI stand on its own. Forget about waiting on the cloud. Why outsource intelligence when you can run locally? So AI models should live together, should live where they need it, on phones, gateway, desktop, camera, processing data instantly without a round trip to the cloud. So whether it's facial recognition, voice assistant, or industrial monitoring, local execution, remove cloud dependency, slash bandwidth cost, and keep data private. There's a seamless update, yeah, no problem. It's like an AI model update on the fly, directly on device without disrupting workflow. So this is AI 101. It's already there, but it's just the beginning. The second stage is contextualization. It's like a AI that understands the bigger picture. Execution is great, but what if AI actually knew when, where, and how to act? AI models that adapt, like a wearable, prioritize health tracking during workouts, but still switches to navigation mode while traveling. Like think smart, not dumb. A thermostat doesn't just react to input, it learns to patterns, adjusting to time, weather, and occupancy. Like self-improving AI model refines themselves in a feedback loop, learning from context to deliver hyper-personalized results. And this is where AI not just work, it anticipates, reacts, and evolves. Stage 3, it's AI to AI communication. So AI to AI communication is where model, they can talk to each other. AI working alone is fine, but AI collaborating like a hive mind, that's where things get interesting. Model to model interaction, it's where AI systems share insight dynamically, improve decision making across networks. There is a collective intelligence in action. So imagine a fleet of autonomous delivery robots optimizing routes in real time to maximize efficiency and and save energy. Like it's cross-domain AI collaboration, like healthcare AI, talking to smart home AI. Now they're working together, making life smarter and more intuitive. This is where AI is not working in silo, it's AI forming an ecosystem. Stage 4, it's AI choreography, like intelligence that dances with reality. At this level, AI is not just reacting, it's self-organized. Dynamic workflow where AI models don't follow rigid scripts, they adjust the actions in real time based on the situation. Like manufacturing robot that sync instantly to production shift. Check, like smart city, dynamically allocating resource. They're done. From automation to autonomy, AI now moves from predefined rules to real-time self-directed action. And this is where AI does not just execute, but it evolves, adapts, and performs at scale. So the bottom line is by operationalizing these 4 stages, we go from basic AI execution to fully agentic AI ecosystem, where intelligence is autonomous, context-aware, self-improving, and seamlessly coordinated across domains. This is not just the future, it's happening now. So it's a new era of AI, and let's build it together. So how does it look without Mimik? So without Mimik, basically you will have an app UI where you will have to bundle an AI model runtime in order to execute the AI model, which means that you most likely will need to embed in your app UI a model management, which means in order to download your model or fetch existing models, which now the execution will talk to this AI model in order to execute the model, so the specified model. Then you create an AI chain. So like you have framework for that, but which is still embedded in the app UI. The AI chain invoke the AI model in order to get some result. Potentially, the AI chain will go to the LLM in the cloud in order to refine the response or enhance the response. And if there is a device in the same context, the AI chain won't be able to do that because how to discover the new element. And this is generally why you most likely will need a cloud discovery where this AI will register to this cloud discovery. And now because you have embedded a cloud-based discovery framework in your app UI, you can discover the generative AI, which is close, which means that now you can talk to it, which means that you actually also need a security framework in order to basically make sure that all of this happen in a secure fashion. So now if a new device arrives, same thing, this will not happen because you will have to have the restoration to the cloud discovery. And once the cloud discovery is achieved because of the security framework, the AI chain on the native UI you're developing is now discovering the new element. And now you need observability on top of this because all of this is not super easy to debug, or you will actually have insight on how things flows. And that's the reason why you have to also embed another function, which is an observability function. So all of this will need to be done for each app UI. So AI chain, AI runtime model, model management, security framework, observability, and cloud-based discovery. And even worse, if you now have another app on the same device, this other app will not even be able to interrogate the existing services because they are completely embedded in the previous app, which means that you will have to redo everything from scratch. So that's basically what's happening if you do AGI without Mimik. It's basically you create huge monolith which are generally not sustainable and very complex to develop. So what Mimik provide? So when we at Mimik, we're not just talking about agentic AI, we're making it real, scalable, and unstoppable. That requires building blocks. That's not just theory, but a framework that actually works. So there's on the core of the building blocks, we have memory. So that's a backbone of the agentic AI. Think about memory as an operating environment built for the edge. So it's a lightweight, powerful runtime that run across multiple OSs and hardware. So it run on device, it actually even run in the cloud now. But because it's not just an OS layer, it's a foundation of decentralized intelligence. What does it include? A microservice execution to deploy, manage AI-driven microservice effortlessly, an AI runtime to execute model directly on the device without cloud dependency, a node discovery, which enable dynamic service context, letting microservice and agent to self-organize. It allows you to create an ad hoc service mesh where you create a distributed AI network at the edge, allowing seamless AI choreography. It provides observability where you see everything, optimize everything. It has zero-touch configuration, so no friction, no hassle, and no manual setup. And zero trust security because security should not be an afterthought. So at the edge, everything can be a threat. So which means that you have to really think security first and not as an afterthought again. So with memory, intelligence is not just executed, it's coordinated, secure, and full autonomous. Then you have a set of edge microservices that power it all. So to make agentic AI fluid, adaptive, and scalable, we've built a suite of specialized microservices that enable seamless AI. One is a model store, which is basically a smart AI model repository that gives on-demand access to AI model via API, either locally on the device or through this ad hoc service mesh. MILM, so it ensures that AI models are always discoverable, whether on one device or across an entire service mesh. MKB, it's knowledge base. It's a lightweight vector database for RAG. So that's where you implement a RAG and you make AI smarter with embedded knowledge retrieval. So now you store your embeddings in MKB in order to be able to retrieve them if needed. MAI chain, that's a command center for AI collaboration. So it coordinates AI model across devices and service mesh. And finally, M-Insight, it's an AI observability offering deep insight into AI agent behavior, microservice interaction, and real-time performance analysis. So this is how AI, or this is how agentic AI become reality. So it's forget about theoretical AI ecosystem, like this is real world, operationalized agentic AI running at the edge on any device in real time. So it's AI is not just deployed, it's choreographed. AI doesn't just react, it adapts and evolves. AI is not just running, it's communicating, coordinating, and executing autonomously. So this is Mimik, this is AI with agency, and it's just the beginning. So how does it look now with Mimik? So with Mimik, you have Mimoi. So basically, you have this operating environment which has the AI runtime, which means that you can run MILM on top, which will use the AI runtime to execute model for inference, which means that MILM can fetch the model from N model store, where basically the models are, in order to basically execute this model and do inference on it. So that's one way. The other way is you use Mimoi, you create MILM, you run MILM on top, and MILM can act then as a proxy for already existing AI agent, which are not necessarily discoverable and which don't have all of what Mimoi has. So that's kind of like two ways to implement MILM. It's either by using the existing runtime or by acting as a proxy for other runtime. Then you create MII chain. So MII chain, this coordinator can now invoke Mimoi to get the context, because Mimoi is contextualizing everything, which means that MAI chain can react. So, I discovered two MILM, therefore I can invoke them. Of course, if there is a knowledge base, MAI chain then can adapt again. Or there is a knowledge base, I will fetch some knowledge from there, even before going to MILM or even before going to a cloud LLM. So that's basically up to the AI chain, MAI chain to basically adapt to the context it discover via interrogating Mimoi. And if a new device arrives, which itself has a knowledge base, has a model, and has a model store, and has a recognition store as a microservice. So all of these services then become discoverable automatically, which means that MAI chain on the first device will discover the model store and can then fetch the information of what has been recognized by the camera in order to do something with it, even before accessing the knowledge base or after, or before accessing the different microservice, either the different AI agent, either locally or through the cloud. Which means that when the camera recognizes something is discovered, MAI can adapt to it and therefore create adapt the solution. Which means that when you develop the app UI, the app UI just need to interrogate MAI chain. So which means that now the app UI is focused on developing like potentially a chatbot which generate prompts. This prompt are passed to the MAI chain, and at that time you can access the different systems. So which means that at the UI level, at the app UI level, you really just focus on developing the UI, because all the logic is now in a set of reusable microservices which run on top of Mimoi. This is where now going back to all the stages. So now you have local execution. So everything happens locally. You don't necessarily need to go to the cloud. Everything is contextualized because MAI chain can interrogate memory in order to say what is the context in which I am. So if there is a new microservice, or if there is a set of a microservice, MAI chain can interrogate, it will do it. This is AI to AI communication. So now you have two AI which exchange information in order to provide a solution. And finally, look, all of this is show a very good example of AI adapted choreography, where MI chain coordinate the different elements in order to retrieve the information appropriately. And then you have M Insight, which basically make all of this observable, and then allow you to trace the different core or know the context in which each microservice is. And then if you develop a new app UI, you have the choice. Either you can access the existing MAI chain because it's actually local API, which means that the other app UI will be able to do that. Now the UI then may be different, but logic behind is the same. Or the new app UI can just interrogate the knowledge base, or the app UI can just interrogate MLM locally in order to do something, or even access the model in order to maybe retrieve the model or download the new model. And finally, the new app UI can create another AI chain, which will then define the new logic, which will be a different solution. So all of this is doable because memory allows you to expose local API, and now you have a set of microservices which help you build the solution without having to overload the app UI into a specific framework which are not accessible. And that's what makes memory extremely powerful. It allows you to expose local API either on the same device or through the service mesh MOE can recognize by discovery. So in 2003, I was at Microsoft, and I wrote this Think Quick paper defining what a service should be and a well-enabled service should be. So it was not just exposing API for functionality. It was about exposing API that define how service behave as part of a system. So that's idea was built on a framework called FCAPS. So it's about fault, configuration, accounting, performance, and security. So ensuring service were not just operational, but they were self-sufficient, resilient, and intelligent. So fast forward to today, and AI is still playing catch up. It's time to bring the same principle to AI agent. So what makes an AI agent well-enabled? To be truly autonomous, adaptive, and operationalized, an AI agent need to be like on offline first. So AI should be independent. If it collapses without cloud access, it's not an agent, it's a liability. It should be discoverable. The AI should announce itself. No more static configuration. No more ghost agent hiding in the dark. Should be context aware. AI need to understand where it's running, not just functionally, but environmentally. It should be observable, and that's the F, A, and P of FCAPS. So fault aware, know when it's failing, accountable, you track the usage, and performance optimize, you monitor efficiency. Zero trust enable, so that's the F of FCAPS. So no blind trust, no weak links, and no nonsense. And it should be zero touch configured. So that's the C of AppCaps. Deploy it, run it, and let's it figure itself out. So how does this happen? It happened at Mimik. We make this AI agent well enabled. So we basically provide via memory and via the set of core microservice, we actually make an AI agent offline first, discoverable, contextual, observable, zero trust enable, and zero touch config. And this is how agentic solutions become real, scalable, and actually useful. And it's because an AI solution that isn't operationalized, it's just a fancy set of API with commitment issues. What is the starting points? So go to developer, create an account on going through console.mimik.com, create account, download memory, and go to GitHub mimik-memory. Follow our documentation in devdocs.mimik.com. We have tons of resource and video under developer.mimik.com. And most importantly, start now. Thank you.